So in this video, we're going to talk about types of pure substances. In the last one, we talked about mixtures, when we physically blended two or more things together. But those things by themselves, if they weren't blended together, would be an example of a pure substance. One type of pure substance is an element. An element is the simplest kind of matter. It can't be broken down any simpler and still have the properties of that element. Now, you can break it down if you use like a nuclear reaction, and you can get smaller subatomic particles out of that element, but it's no longer going to have any of the properties of that original element. Elements are made up of just one kind of atom. For example, this gold bar here, if it's pure gold, is just made of just gold atoms. There's no other elements mixed in of any kind. That's why it's a pure substance. Compounds are another type of pure substance. Compounds are substances that can be broken down by chemical methods. When you break a compound down, the pieces have completely different properties than the original compound. A compound, of course, is made of two or more atoms that are chemically combined, not just physically mixed. There's chemical bonds linking one atom to the other. So here's an example. This is salt, table salt, sodium chloride. Sodium chloride is made up of sodium. Sodium is actually a metal. It's this really silvery soft metal. It's so soft you can cut it with a knife. The other component in this compound is chlorine. Chlorine is a gas. It's this kind of greenish fuming gas. And they have completely different properties than table salt has. Sodium, for example, if you throw it in water, it explodes and it ignites the water and turns it into hydrogen and it explodes. Chlorine, if you inhale it, it'll kill you. It was actually used as a weapon in chemical warfare since the World War I. But if you put it together, you have table salt, which is kind of interesting. Next, what we're going to look at is a comparison of compounds versus mixtures. Compounds are made of only one kind of material. So if I have a compound like salt, it's just sodium chloride, sodiums and chlorines and nothing else. That's what I mean by one kind of material. A mixture, of course, is made up of more than one kind of material, at least two. A compound is made by a chemical change. There's chemical bonds linking the atoms or the elements of the compound together. A mixture is made by a physical change, just a blending or a mixing or a dissolving. Compounds have definite composition, and what I mean by that is the composition is always the same. For example, sodium chloride is always one sodium for every one chlorine. Water is another example of a compound, H2O. It's always H2O. I can't have H3O or H2O2. It's no longer water at that point. The composition has to be two hydrogens for every one oxygen. A mixture, of course, has a variable composition. You could make Kool-Aid with 1 cup of sugar, or you can make Kool-Aid with 2 cups of sugar. It's not going to be the same tasting Kool-Aid, but it's still going to be a mixture of Kool-Aid. Okay, so next what we're going to do is some example questions where you need to classify something as an element, a compound, or a mixture. So this is a particle diagram, and this is just one type of atom. So, of course, it is an element. This is different atoms. We have yellow atoms and we have red atoms. So, of course, this is a compound. And the reason it's a compound is not a mixture is that it is in a definite composition. On all of these little compounds, there's always one yellow for every two reds. And this one here, of course, is a mixture. They're not chemically combined. None of the atoms are touching. They're just physically blended together. We have yellow atoms and we have red atoms, but there's not a definite composition and there's not a chemical bond holding them together. Okay, so compounds can be broken down into simpler substances by chemical means, but elements cannot. You can't do a chemical reaction to break one element down into something smaller. A chemical change is a change that produces matter with different composition than the original matter. So if I do a chemical change to break down a compound, for example, if I break sodium chloride into sodium and chlorine, those components, those products have different composition and different chemical properties than the original salt had. So a chemical change is a change in which one or more substances are converted into different substances. We're going to talk more about chemical changes in the future here, but one of the key pieces of evidence that a chemical change has happened is that light and heat are often produced in a chemical change. So like we said, compounds have quite different properties than their component elements, and it's due to a chemical change that the resulting compound has new and different properties. We talked about table salt. Here's another example. If I take carbon, which is this black solid, and I take hydrogen gas and I mix it with oxygen gas, and I do so in a ratio of about 1 to 2 to 1, I get sugar, table sugar. Okay, next what we're going to look at is a little flow chart that you should have in your head whenever you're trying to classify matter as what type of matter it is. So if I have matter and I ask myself the question, can it be separated by physical means? The answer is yes, it's a mixture. You could separate it by something like filtration or chromatography or distillation like we talked about in the previous video. If the answer is no, I have a pure substance. If it's just one type of thing and I can't separate it, it is a pure substance. Okay, if my mixture is uniform in composition, then it is a homogeneous mixture. If it's not uniform in composition, if the answer is no, then it is a heterogeneous mixture. Okay, back to our pure substances. If we ask ourselves the question, can our pure substance be decomposed by an ordinary chemical means, like a chemical reaction? If the answer is yes, then it's a compound. If the answer is no, I can't take that substance and break it down any smaller with a chemical reaction, then it is an element. So this little flow chart is really important. I want you to write it down in your notebooks, but you're going to probably have to memorize this at some point when you're trying to classify matter. You go through this enough, you do enough examples, this will become really easy. Okay, next we're going to talk about elements. So there are currently 118 elements on the periodic table. They all have 1 or 2 letter symbols. And a compound is going to have a formula, which is just a combination of the symbols that make up that compound. The element's first letter is always capitalized, and if there's a second letter, it's always lowercase. So on your reference tables, you have a periodic table of elements that looks like this. You can see the elements are listed. We'll talk later about how this table is organized, but right now I just want you to learn about how to look up elements and find their names. So if you look at the table, you'll see that there's no names, but you have the symbols, you have the letters, and you also have something, a number here called the atomic number. So here's the atomic number for carbon. It's 6. Now you know it's carbon because I just said that, but if I asked you another element, what its name was, if you just look at the atomic number and then turn to table S, it has a list of all of the elements and all the atomic numbers, and it's listed by atomic number, so you can find the number and then look up the name. There's a whole bunch of other things on this table S that we'll get to in later videos, but right now I just want you to be familiar with the reference table, the periodic table, and then how to use table S to find its name if you need it. Okay, so let's wrap things up here. Elements are just one kind of atom, and they're all organized on the periodic table. They can't be broken down and still have the properties of that element. A compound is more than one kind of atom, and it can be broken down by a chemical change. When you do this, the products have new and different properties than the original compound. You're going to need to be able to classify a sample of matter as either a homogeneous, heterogeneous, a compound, or an element. That flow chart will help you here, but like I said, you're eventually going to need to be able to do this without a flow chart, and we'll practice this in class. That's it for this video, and if you have any questions, please let me know.